Yeah, so let's define a matrix. So 1, 2, quickly I will define a matrix. Yeah, so yeah, this is a matrix. A is a matrix. So how do you? Yep. So yeah, A is a matrix. Yeah. Right. So A is a matrix. Yep. So if you add a semicolon at the end, yeah, you don't see the output, right? Okay, let's here look at the space, yeah, workspace. So look at the dimension. Dimension is 3 by 3, and this is the value. Yeah. So how do you find the dimension? Yeah, you can find the dimension very easily. So size of the, yeah, so name of the what is the label? A is the label, yeah, of my matrix. So variable name is A. Yep. So how do you find? Yeah. So the dimension, where is it? Yep. Size. You can use syntax called size to find the dimension. Yeah. So there are 3 rows and 3 columns. So this yeah, syntax is very useful to us to implement, for us to implement the code, right, later up. So when you solve system of linear equation, yeah, this syntax is very useful, right? So we have to read this the number of rows and number of columns. So for that we use yeah, size. And I will define another, which is also matrix. I will define a column vector. How do you find? Yeah, define a column vector. Yeah. So in the first row, it has only one element. Yeah. So like this, you can define a column vector, right? Okay. So right. So you can add two matrices. When you add two matrices, what do you get? When you add two matrices, do you get a real number or what do you get? When you add A and the same dimension, let's assume, otherwise you cannot add two matrices. The dimension should agree, must agree. If you want to operate, if you want to add or subtract two matrices, the dimension should, yeah, must agree. Otherwise, so when you add two matrices, what do you get? This would be a, again, yes. When you add these two, be a number or matrix, the same dimension. Yep. So the matrix addition is a binary operation. Yeah, binary operation. Yeah. So when you add two matrices, but make sure that this dimension agrees, right? So when you add, so let's say M is a matrix, N by M. Yeah, matrix addition is a binary operation, right? When you perform this operation, add or subtract, yeah, this is a binary operation. Yeah. So okay, and yeah. So what can you say about the matrix multiplication? So matrix multiplication, is it a binary operation or not? Matrix multiplication. Yeah. So I will find another. So I will define another. I will fill this matrix with zeros. So how do you do that? Yeah, so you have to type zeros, and you have to enter the dimension of the matrix. If you have a square matrix, 3 by 3, I just put 3. But if the dimension, let's say you have a rectangular matrix, yeah, so then you have to put the dimension correctly. Then yeah, so you will get here 3 rows and 3 columns, filling with zeros. So let's say I want to get a, so I want to fill with ones. So, and the number of rows and columns are the same. So see, filling with ones, right? So, and if you look at the dimension of A and C, they have the same dimension. Then I don't know, something happened to my internet connection. Again disconnected. Something happened to my. So like that you can define matrices, you can find the size of the matrix, you can operate two matrices. When you operate two matrices, make sure that you you check the dimensions, the dimensions, right? When you, so definitely you can multiply these two matrices, because the inner dimension, multiply these two matrices. Why? The inner dimension, if you look at A is 3 by 3. A is 3 by 3, and this is A, and C also 3 by 3. 3 by 3. If you look at the inner dimension, they are the same. Then you can multiply. The matrix multiplication is defined, right? So you can multiply matrices, these two matrices. So like that you can operate matrices, but make sure that a matrix multiplication is not commutative. So it is not commutative, right? Here, AC is not equal to CA, right? But matrix addition is commutative. This operation, addition or subtraction, is commutative. So you can show that matrix addition or addition. Addition is a group, right? Group one. So it is a group. Matrix addition, matrix multiplication. Matrix addition is a group. And so matrix multiplication is not commutative, right? A times C is not equal to C times A. Okay, so this is commutative group matrix addition, because A plus C is same with C plus A. Okay, so brush up your knowledge on those things, linear algebra. So you can define column vectors, and you can check the size by typing size of the matrix or vector, right? And so you can combine two matrices here. So like this, you can combine, or you can extend your matrices. So this is another. So you can extend. I will bring. So I have a matrix A here, matrix A and matrix C. I will take yeah, I will bring this matrix. I will put this matrix to here. So how do you do that? So very easy. Yep. So I will define another matrix called D. So how do you do? Yep. So I extend the matrix A. That means I will add this matrix to A here below, right? So break and add C. So like that, you can extend your matrix or you can delete. So my D, if you want to find the size, just use the size, syntax called size. Yep. So it is 6 by 3. It has 6 rows and 3 columns. And you can delete, let's say I want to delete the last row, the 6th row. So how do you do that? Yeah, you can, so you can, before that, let's retrieve the last row. Okay, let's retrieve the last row. So how do you retrieve the last row? Yep, so here, this is round bracket. So when you define the matrix, you have to use square bracket. When you retrieve the matrix D, you use round bracket. Yep, so I want to read the last row, the entire row. So like this, yep. So when you retrieve the data from somewhere, information, you use round bracket. When you define square bracket, define square bracket. Yep. Yes, I want to delete this last row. How do you do that? Yeah, very simple. Yep. So I will delete the last row of D. Yep. So last row, kill the last row. Yep. So I will kill the last row. Yep. So here. So earlier we have one ones, 3 ones. Now we have 2 ones. Then you can find the size of D. Yeah, now we have 5 rows. So like that. And yeah, so like that you can manipulate your matrix, extend or delete, or let's, so you can manipulate. Yep, so let's delete the final last column. Yep, so, so I'm pressing the arrow keys to get the previous syntax. So this time I'm deleting the last column. So, now I can plot if you like, plot if you want to. Yeah, so I'm not sure whether I use round bracket to. Yeah, so so first column against the second column. Let's see. So get familiar these syntaxes. I think, yep. So here we go. Yep. Yep. So yeah, joining these points, the octave joining these points like this. So like that, you can play with matrices all the time when you do programming. Give me a second, right? Give me a second. So yes, like that. Linspace is very useful when it comes to putting a graph. Yep, so linspace, and there's a double call. So colon operator. So it is also the same. Right, so this is the starting point and this is the ending point, left end, and right end of the interval, and this is the increment. So you can define this increment here. So here you cannot define the increment. Here you have number of points inside this interval, but here you can define the length of the subinterval. So this is basically length of the subinterval. Yeah. So here, so if you not specify, if you are not specifying this length of the subinterval, so length default one is 1. Yeah. Size of the subinterval is 1. If you don't specify the length of the subinterval. Yeah, this is the length of the subinterval. Yeah, this is the number of points you are going to include between 0 and 10. Yeah, so these two are very good. Very useful when you discretize your independent access domain variable. Okay. So indexing, right. So yes, so almost 10 o'clock. So indexing, you can, as I said before. So let's say I had a so you can retrieve data. So let's say I want to read this data, this element. So look at what is the position of that element located. So it is located in the first row and the second column. So when you retrieve data, put the position. So inside the round brackets. So put the position, then you can retrieve that data, right? So like that. So if you want to retrieve the entire first row, so put put the row number with the colon mark, and let's say I want to retrieve this block here. So let's retrieve that block. So from row 2 to 3. So from row 2 to 3. And from column 2 to 3. From column 2 to 3. From column 2 to 3. And like that you can retrieve. So those are excellent. So yes. And the other useful so syntax is min max, let's say. So here we go. So so let's say, do we have so I have d. Let's find the maximum of this column. We need that, right? So max of which row? This row. The second row. Max. But if you define in this way, you can find the index as well. So maximum value, you can retrieve the maximum value as well as the index, the position located, the maximum value. So how do you do it? So this is the syntax. So this will grab the value, max value. I will put max val, just type a name, right? And this is the position. Position. Max value is 6. Position is, it is located in the second row. Yeah, like that. Yeah, max min. Yeah, these are very useful. Yeah, syntaxes. Yep. And you can find. Yeah, you can define a condition. Then you will get. Yeah, you can. Yeah, so yeah, play with these syntaxes, right? So get familiar these things. You need these things. Carry out projects. Yeah, plotting tool. We discussed that. Yeah, if you have a few number of coins, you get this. Yeah, yeah, clumsy pictures. Yep. So if you increase, yeah, so a lot of points. Yeah, you get smoke. Yeah, right. Yeah. So and this one. Yep. So yeah, you can. Yeah. So here you can define functions as well. So how do you do that? Yeah. So function. So file here we have new file. Where's the no, if you go to the editor, here we have file. So now here new function. New function. Name of the function. I will put my func. Right. So you can put any name, right? You can put any name. Right? So then, okay. So remove this cover. We don't need this. Remove. So this is your function. Yeah. So this is the function name. And if you have, so these are the inputs. Yeah. So let's say A is my one of inputs and B is the next. Can, yeah, put many inputs you like. Yeah. So, yeah. So what else? If you have output variables, yeah, you can define in this way, right? And in this, yeah, so in this file, yeah, you define your function. You define your function. You can customize. You can customize your function. So right. In addition to your build, yeah, in addition to Octave built-in function, yeah, you can define your function here and save this function up. So I don't save this like this. Yeah, can, yeah, define a function and adding inputs and output variables, right? Yeah, familiar with these things. Another thing, yep. So yeah, so these conditional, yep. So these loops, conditional. How do you say for, yeah, control statements? How do you say this? While loops and for loops, yep. And switch. How do you, yeah, so break, get familiar these, if you know programming language. Yep, so you will learn these things, don't worry. Yeah, you will learn if you don't know, if you didn't follow the first year course, if you don't know any programming language. Yeah. So you have to put a little bit effort to learn these for loops and while, yeah, so these things, yeah, these are very, yeah, useful, right? When you, yeah, do programming, when you do coding, yeah, so these are very useful, right? Yeah, brush up your knowledge on these things, right? So that is very, yeah, so this is quite, okay, plotting, yeah, you can customize your plot by, can change the, yeah, color of the graph, and you can introduce styles like this, right? Yep. So yeah, just play with these codes. Then you will realize that you can customize your graph or plots. You can put three-dimensional graphs, and this is the, yep. syntax familiar. Yeah, subplots. Yeah, you can plot two plots in the same diagram. Yep. So you had to put. You had to use the syntax subplots. Yep. So yeah, this is yep. So any questions? This is what I wanted to mention in the warm-up class. Yep. So if you get familiar these syntaxes and these things, then I think this is helpful for you to yep, carry out your do your projects. Well, yep. So any questions? So before that, let me play with another thing. So if you want to remove so memory, so here you will see these variables. If you want to clear this this variable, or if you want to get rid of these variables or clear memory, so how do you do that? Clear all. Yeah, so clear all. When you type this one, here look at this workspace. Yeah, it comes empty, right? Yeah, clear this screen, and I will let me play with this. Finally, let me play with this matrix. Yeah, so so this is so this is 5 by 5 square matrix. Filling with random numbers between 0 and 1, right? Okay, so how do you find the determinant? Let's so very easy. Determinant of a and if you want to, let's say, eigenvalues. So because first project from the linear algebra one, you need these things: determinant, eigenvalues of a. Yep, eigenvalues. Transpose. You know how. Yep, so transpose. Yep, and let's say I want to see the upper triangular matrix of A. So how do you do that? Triangular matrix upper triangular matrix of A. Lower triangular matrix. Huh? So get familiar this syntax. And what is the diagonal of the matrix? Let's look at the diagonal. Yep. Yeah, this is the diagonal. How do you obtain the diagonal? So just there's a syntax in Octave. Yeah, and you can use that syntax. So this is the diagonal. Let's put this diagonal in nice way. Let's fill with zeros, and let's place this diagonal in a nice manner. How do you do that? Yeah, so your diagonal of of a. Yep, so 0. Yep, so here we go. So this is the diagonal matrix here. So this is the diagonal of A. I'm filling with zeros. Yeah. So this is really a diagonal matrix, right? So like that, yes, yep. So yep, like that you can play with these syntaxes. Or yep. So these are the basic syntaxes you need in this course. If you get familiar these syntaxes, I think that's you are done. I think. Yep. So then you are ready to get any any project. So if you know the numerical analysis, then with these syntaxes, and you can handle any, can solve any, yeah, problem related to, yeah, so any problem, real world problem, not any problem assigned by yeah, so given by me. Yeah. So if you know these things, if you have an idea about, if you know, get familiar, try to get familiar these syntaxes with the numerical analysis a little bit, right? Then you are ready to go, right? Okay. So this is the warm up class. That's it from me, from my side. Now you will do LMS. Uh, So I will open this activity. Yeah, so you can take a break. We have time, right? So it's almost 10 o'clock. I think 15 minutes past 10 o'clock. Yeah, I think we better take I think a small break. Yep. So yeah, 15 minutes or 30 minutes. So now let's ask them. Yep. So the next section you will do this activity. I'm not stop recording.